Our next discussion is about the nonmetals. So again, we just covered all the metals in this chapter. We're now going to move into our nonmetals. Nonmetals are going to vary in properties. Some are going to be poisonous, some are highly reactive, some are completely unreactive at all. Some are necessary for life. So I mean, some will kill you, some will make you live, some will react, some won't. So we do get a very, very, very wide variety of properties. So try to keep that in mind. Properties are non-metals in general. So in general, for the most part, they are poor conductors. They do not uh, conduct heat or electricity. In fact, these are what we use as insulators to stop the flow of heat and electricity. For the most part, with the exception of your noble gases, that group 18 that don't react at all, they are very reactive. Um, our solid ones, or whenever you decide to put these into solids, a lot of them require a lot of temperature decreasing due to the fact that they are naturally occurring as gases, are going to be dull and brittle. So they're going to lack luster, they're going to crumble when you try to hammer them instead of become a sheet like metals do. They kind of just break apart. Physical properties. 10 of the 16 nonmetals on our table are gases at room temperature. 1 of 16 are liquids at room temperature, and 5 of 16 are going to be solids. So even at that sense, they are very big variety of different things happening here. They're going to be considered pretty much the opposite of metals. So they're going to be dull. Metals were shiny, these are going to be dull. Metals were hard, these are going to be brittle. Metals were good conductors, these are going to be poor conductors. They're also going to have low density to them, so they aren't going to be as compact, so to speak. That makes sense because most of them are gases or one's a liquid, bromine's a liquid. So most are going to form compounds. Most are going to be reactive, and they kind of do the opposite of metals, as instead of gaining or losing electrons, they want to gain electrons. So keep that in mind. Or they want to share them. It's possible to share. Fluorine here is our most reactive metal on our table. So the most reactive out of all those elements is fluorine. And you can see from Bohr's model here, fluorine has 2 shells of electrons. You have your nucleus here. Your first shell at least has 2 electrons, and that's filled. Fluorine's happy with that. Your second one can hold 8. However, fluorine has 1, 2, 3, 4, 5, 6, 7, which means anything that is willing to give up an electron, just one, that's all it needs, will react with fluorine. And therefore, fluorine is going to be the most reactive on our whole table here.